Good morning, good afternoon, good evening. This is Helen Thomas and the CDFM study group. We will continue review of CDFM Module 2, Competency 2, which is Cost and Economic Analysis. Let me close this. So today we'll wrap up Cost and Economic Analysis, and then next week we'll pick up with Strategic Planning and Organization Performance Management on 31 May. Then 7 June, we will do module 3.1, which is fiscal law. As by now, you should figure out that fiscal law accounts for the majority of the questions on all three of the exams. So as we go through module 2, we're going to pick up at the end, we're going to pick up module 3.1 again, which is fiscal law, to ensure that we've incorporated all the fiscal law from module 1, 2, and 3 on the module 2 exam. So you would have covered all of it. And then 14 June, we will do module 2 review, and whatever is left on 21 June, we'll cover it there again. So that is the remaining schedule for us to cover CDFM module 2, competency 1, 2, 3, and fiscal law. All right, let me get my glasses. All right, so last week we ended up talking about the life cycle costs, the various types of life cycle costs, and also we looked at acquisition categories, ACAT 1 being a major category, ACAT 1AM, a major automated information system, MAIS. And then we talked about the milestone decision authority. Who is the milestone decision authority for ACAT 1 Delta, those major acquisition programs, which is the Undersecretary of Defense for Acquisition and Sustainment. If it's at the component level, it'll be ACAT 1C, Charlie. So I'm just trying to recap some of the things we talked about. The MAIS, Major Automated Information System, the major category is ACAT 1A, the A telling you it's an automated system. ACAT 1AM is at the DoD level. ACAT 1AC is at the component level. You have two exceptions for the acquisition categories, Milestone Decision Authority, which is SOCOM, Special Operations Command, and Defense Logistics Agency. They have their own acquisition milestone decision authority individual or senior acquisition person. So those are the two exceptions. Let's see. We also talked about the phases, the milestones of the acquisition process, but everything starts with understanding that the big op order is the national security strategy, is the president and his forum and his council determining what the priorities are for the country, what the goals are, what the deficit, whatever those priorities are for the country. And then they publish their big op order to the subordinate agencies, such as the Department of Defense. Department of Defense takes that big op order, the national security strategy, and pull out the defense-related things that the Department of Defense is responsible for doing, and they come up with the national defense strategy. Part of that strategy is the national military strategy, which is created by the chairman of the Joint Chief of Staff, who's the senior military advisor to the president, the Secretary of Defense, and the National Security Council. We talked about the phases being material solution analysis. So the 3 DoD support system being JCITS, Joint Capabilities Integration and Development System. That's where you identify capability gaps by looking at doctrine, organization, training, material, leader development, all of that. And if it's a material solution, it triggers the defense acquisition system. If it's any of the other things that will require to fill that capability gap, it'll be the PPBE process. So it's either using the system for JCITS, PPBE, or the defense acquisition system. So in the acquisition side, you have material solution analysis. Once you identify what the capability gaps are, the JROC, Joint Requirements, so I'm telling a story, the Joint Requirements Oversight Council, who's chaired by the Vice Chairman of the Joint Chief of Staff, will then determine not just what the gap is, but they have their recommended solution that is published in an initial capabilities document, the ICD. So once you have the solution, suggested solution, then you come up with courses of action to fill that. So in the material solution analysis, they're looking at the various courses of action or analysis of the alternative. Then the next one, once they get all those key performance measures, parameters, key systems attribute, what does this system need to be able to do? And they come up with the solutions, then you move on to milestone A. Approval in milestone A does not initiate a acquisition program. It's not until milestone B. After milestone A, you have technology maturation and risk reduction phase. And the purpose of that phase is to reduce all the technology, the engineering, how you integrate it into other system types of risk. Milestone B, again, is the formal initiation of a program. You identify the acquisition program baseline, that's your starting point for development of that capability. You establish the LRIP, the low rate initial production. That's the smallest amount that they're going to develop initially and test it to make sure it actually fills the capability gap. All of that data is published in an acquisition decision memorandum. The next phase is the engineering and manufacturing phase. Once they approve, the milestone decision authority approves in milestone B to go ahead, they enter the EMD phase. In the EMD phase, they get ready to develop and build that particular capability. So they do the developmental testing and evaluation using RDT&E and procurement funds. They're making sure that it meets all the attributes and parameters that were established early on before they move on to milestone C. These are all decision points, these milestones. Before you move on to from one phase to the next, it's a milestone. So let me pause. Ms. Henderson, can you hear me? Let me make sure. And do you have any questions? Or you can just raise your hand or something, wave or something, so I know that you can hear me. Okay, thank you. All right, and after approval in milestone C, you move on to the production and deployment phase. And the purpose of that is to achieve operational capability, to actually develop the item to the point where you can send it out to the warfighter. So you establish the initial operational capability date of when you're going to have those LRIP items developed and ready to push out. And you develop that. Full rate production before you actually develop. Go ahead, Ms. Henderson. I see you're off mute, but can you hear me? Okay, I cannot hear you though. So at any time, if you feel like chiming in, please do so. I can see that you're off mute, but I can't hear you. All right, so before they actually develop all the items, they have to have another decision point, which is the full rate production decision or full deployment decision. And that is the point where the milestone decision authority looks at all the data and determine if they're ready to develop the rest of the capability item. And then the final phase is the operations and support phase. That's where we use our O&M and MILPERS, because from cradle to grave, once you dispose of the item, once you sustain it, you have to have money to do it during that life cycle of that particular capabilities. So I would say if you see the question, which is the most expensive phase, it is typically the operations and support, because most of the life cycles, whether it's 5 years or 6 years, so the most expensive one is the operations and support phase. So just kind of recapping some of the important things here. So we did all that. All right, so where we're picking up today now is on page 2220. The life cycle cost composition. How do we break down the cost of the development of the items in their life cycle from the cradle to the grave? And so if you look at the chart on page 20, you see number one, all of those items in that big old box make up the life cycle cost. So we're going to look at the individual items. If they say, what is the development cost? They might give you a bunch of different costs, and development cost is anything, all your RDT&E costs is considered development costs. So if you get RDT&E, procurement, MilCon, O&M, MilPers, and they say you need to calculate the development cost. Anything that's RDT&E, if you add it up, that is your development cost. This is an extremely important slide for you to understand. Flyaway cost. So you develop cost. Flyaway cost is procurement of the prime equipment. So you look for anything that say prime, or the main item is your flyaway cost. So if it has several prime costs, then you need to add those together to come up with the flyaway cost. The third cost is your weapon system cost. And if you look at the diagram, you see the dotted rectangle around flyaway costs, and you see flyaway costs, which is procurement of the prime equipment, and procurement of the support equipment is considered to be the weapon system cost. Number four, procurement cost. So anything that uses procurement dollars, add up all your procurement, and that is your procurement cost. Number five is your MilCon, military construction, that you pay for your facilities. So if you see it again, it's going to say, what is the MilCon cost? And you add up everything that uses military construction dollars. That is the total MilCon cost for that development of that item. Now on the chart, you see number 6 is operations and support phase. Operations and support uses O&M and MilPers, and you also dispose of the items at the end of the life cycle. So when you add up the developmental, flyaway, weapon system, procurement, MilCon, operations and support, and disposal costs, which is your O&M, all of that together is your life cycle cost. You will probably have to do calculations in this if you see this particular problem again. And I think at the end of this section, it actually has in the practical exercise some examples. So once I get there, I'll go over it. Some other calculations you're going to have to do in module 2 is on page 2221. You have to establish the unit cost of developing or acquiring that equipment. So page 2221 of your book, for example, they give you RDT&E costs for one item is $5,000. Procurement, $199. You're procuring 199 units for $20,000. Military construction, no units, but I have $1,000 there for a total of 200 units at a cost of $26,000. That's a total. And they may say, well, calculate the PAUC, the program acquisition unit cost. The PAUC is everything, RDT&E, procurement, and MilCon. So they already total it for you. But I promise you, if you see it on an exam again, it probably will not be total. You're going to have to know that the program acquisition cost is adding up all your RDT&E, procurement, and MilCon dollars together. And when you divide that total by the total number of units, you get that unit cost, how much it costs to develop that one particular item. So the example is given on page 21 for the PAUC, program acquisition unit. Whenever you see the word unit, it is telling you they're asking you for development of an item, one of those items. You also will have to calculate the average procurement unit cost. What is that? They give you RDT&E, you have none. Procurement, you have 199 units for 20,000 and no military construction for a total of 199 and 20,000. Same thing, if they ask you for the unit cost, they didn't ask for the total, they asked for the unit cost. That tells you I got to divide. So you take the total dollar amount divided by the total number of units, and it'll give you your APUC, which includes only your procurement funds. So let's say in a practical exercise, or if you see it on a test, and they give you RDT&E, procurement, and MilCon dollars, and they say calculate the average procurement unit cost, you know you should know you're only pulling the procurement dollar amount to establish and calculate the APUC. So make sure you review that section extensively so you know how to do your calculation. On page 2-22, you will see a chart, common life cycle costs. This is, again, repetitive of what we saw on that chart. On page 20, they give you the term, development cost, the explanation, the appropriation that is used, the WBS content if it's used, and the life cycle cost categories. Make sure you review this chart also. Page 2-23 is going to start going into cost estimates. So as they're coming up with the cost of things from cradle, when I develop it, to when I dispose of it years in the future, then you have to have cost estimate to come up with the baseline, the starting point. And so on page 2-23 for acquisition 1 programs, the one telling you it's a major program, there are normally 3 life cycle cost estimates that's prepared at different levels. Everything starts with your program manager. Program office estimate is done by the PM and at that level. So the initial cost is done by the PM and it's called the program office estimate. Then the second cost estimate, that's the next level up, is at the component level. It is the service or component cost analysis. The component cost estimate, that's number 2. 1, 2. And once it gets to the DOD level, it is an independent cost estimate. And who do you think is responsible for that independent cost estimate at the DOD level? That is the DCAPE, Director of Cost Assessment and Program Evaluation. So at this point, we've learned that the DCAPE is responsible for doing the independent cost estimate, the ICE. The DCAPE is responsible for the programming phase of PEB. I'm writing these down. The DCAPE is responsible for providing guidance on the analysis of the alternative. And the DCAPE is responsible for updating the future year defense program. So that's at least 4 things that we've learned throughout these study guides that the DCAPE is responsible for. Definitely important. So program office estimate done by the program manager. Then it goes up to the Army or component level. the component cost estimate, and then it goes up to the DoD level, which is the independent cost estimate. So those are your three basic estimates for all Acquisition 1 programs. And so we touched already in 24, 25, your costs can be broken down by WBS, work breakdown structure. So depending on how the work is broken down, you can associate a cost with each one of those milestones on that particular work problem. So I'm not going to go over the WBS. A key term on page 26 that you need to be familiar with, cost as an independent variable. Right? It's easy to differentiate picking item A versus item B if you're going to, okay, well, this one's cheaper, right? Cost is independent. So once you consider the objectives, the attributes, the parameters, and all of these choices can meet that, then you pick in most cases, you pick the cheapest one that can actually get the job done. So the term cost as an independent variable is very important. In the acquisition I mentioned last time is that the purpose of the whole acquisition process is to minimize, maintain the risk of cost risk, schedule, and performance risk, to manage that so that things don't go out of whack with your costs or the contract will take too long to get the job done. Does anyone have any questions at this point? I usually like to take a breather here. Okay, I hear no questions. So on the bottom of page 26, the first bullet, the key objective with the cost as an independent variable is the best time to reduce that cost is early on in the process. So if you think about the various phases and milestones, that's what they're doing. They're trying to manage cost, schedule, and performance risk so that they can go ahead and make those corrections early on in that process of the developing that item. Page 27. Let's see what they say about the DCAPE again. Normally, so we already talked about the cost estimate, the independent cost estimate being done by the DCAPE, so that's a repeat. All right, so let's talk about some different cost estimating methods on page 2 to 27. So we said the best time to reduce costs is early on in the process. And then when you're coming up, or the program manager is coming up with the acquisition program baseline, they got to have a starting point. How are they actually getting those numbers? So there's several techniques that can be used. On page 28, you have the first one, analogy approach. So you're going to need to know the difference between the various cost estimating methods. And even though I don't actually see the exam, I guarantee one of these will be on there because every DAU, Defense Acquisition University, every cost analysis class that I've taken, it always talks about cost estimating methods. So analogy is assuming that you have one similar item already in your inventory. So you're using the cost of developing and paying for that item as your baseline. Analogy, I have one existing system already in the inventory, so I can use the cost of developing that one system as my starting point for developing the new capability. Estimating method number 2 on page 29, parametric. So analogy is, let me make sure I do this correctly. It's usually easier, quick, because you already have something similar in your inventory. So you already have the cost developed, looks like an existing system. It's easier, it's quick, inexpensive. On page 29, the opposite is statistical, top down, more time consuming, right? And then the key about the parametric approach is I don't have one item that has the same capability of what I'm trying to develop. I may have to take several items that has, okay, I need a GPS, something with a GPS. So I get the cost for that. I need an aircraft that has the rate, that's a certain type of aviation equipment in it already. So I get the cost for that. And you take all the individual costs for the different parts of it, different attributes, and then I put them together to come up with my estimate. So that is the parametric approach. Several existing systems, they don't exactly look like the one I'm trying to develop, but I take the individual costs of developing those certain attributes, put it together to develop my estimate. The third approach is the engineering approach. When you take the engineering approach, if you read through that section, it says there's no existing systems, nothing for me to compare it to. So I got to start from scratch to develop the cost of developing that item. As it says, the strength, it means you're very accurate because, again, you're going to actually look at the individual parts of developing the item. Limited, but it's got more weaknesses than strengths. Very expensive to prepare, very time consuming, difficult to analyze those what ifs, and usually performed by contractors. So that is the weakness of the engineering. So just in case you're asked, okay, which one is most ineffective, less expensive, which is less expensive, which is more expensive, which one is better. So make sure you review which one is quicker, because depending on the timeline that you have to come up with an estimate, you may not be able to do an engineering approach because that's going to be too time consuming. So that was number 3. And then page 31 goes into actual cost. That means we already have some of these aircrafts in our inventory or weapon system in our inventory, and we just use the actual cost that's there. Very accurate because we already have those. It may mean that we needed more developed than what we had so that's the capability gap. We have some, but we don't have enough. We need to develop more. So that's the actual cost approach. Analogy, parametric, engineering, and actual cost. Or you can use expert opinions on page 32. Expert opinion using that Delphi technique is basically getting the opinion of several experts, and you kind of look to see if there are any repetitive theme or recommendation from each of the experts, and you kind of develop your estimate, your consensus from the group to develop your opinion. So those are the various cost estimating methods that you can use in the acquisition process. On page 233, it goes into the learning curve theory. So the idea with the learning curve is the more a person does a job, then eventually the time that it takes to do the job, your output should double. It should take you less time to do it, and your workload, you should be able to do more because you're doing it. So you are definitely going to have to do some calculations once they ask you for, okay, what's the learning curve in this scenario? So we're going to look at those on page 34. So you have some examples of learning curve, how you apply it. You have in the middle of that page, you have type 1. Let me highlight type 1 and type 2. That means you're given certain data, and then they're going to ask you a question. So given the time required to produce a specific item or unit and the learning curve, determine the labor cost to produce the double item. So think of doubling in learning curve. So let's see what's given. So the time required to develop one unit is 300 hours, and they give you the learning curve percentage is 90%. Determine the hours required to produce unit 2, unit 4, doubling. So unit 1, so you take that 300 hours times the learning curve, which is 90%, and it equals 270 hours. So it requires 270 hours for you to develop unit 2. And then unit 2, you take the 270 times the 90% learning curve, and then it'll be 243 hours. It's going to take you less time to develop the 4th unit, and so forth. So in this scenario, if they ask you, okay, for unit number 8 or number 16, because you got to double, what is the labor hours? Then you're going to follow the same process. You take the hours from the previous one times the learning curve, and that'll tell you the hours for the next doubled unit. So that's type 1. Or type 2, they don't tell you the learning curve percentage. You have to calculate the learning curve percentage. They give you the unit and they give you the hours. So for unit 2 at 250 hours, what's the learning curve to unit 4? And basically what you have to do there, let's see. If for most people, they used to using calculators or their phones. On these exams, you're not going to be able to use those. So you're going to have to be able to calculate. So a roundabout math way is depending on the responses on an exam. Let's say they have 60%, 65%, 75, 85, 95. Those are your choices. I would take 65% times an hour and see if I get the unit hours for the next unit. And take 75%, 85%. And eventually, when this example on page 34, I think the learning curve for this one is 95%. Because if you take 250 times the 0.95, you should get 237.5. If you take the 237.5, that's on page 34, times 0.95 or 95%, you should get 225.6. So that's one way you can do it on an exam. Instead of trying to divide and all of that, you just take the answers, the answers that they give you, and you multiply times the hours for unit 2 and see if you get the same hours for unit 4. That's just a trick in doing testing technique. All right, so we did learning curve, families of contracts. You got fixed price contract, cost reimbursable. Make sure you review those. I'm mainly focusing on the areas where you have to do calculations because there's a lot of them in module 2. EVM is a big area also with acquisition. That's the earned value management on page 37 to 237. And basically, this is a tool that's used in the acquisition field to keep that contractor and that government's contracting representative communicating according to the progress of their cost, schedule, and performance, and making sure that everybody is performing to that baseline, performance measurement baseline. So we're going to look at budgeted costs of work performed. All right. Earned value management, on page 38. I'm going to brush over the verbiage, but I want to get to the chart on 39. So you deal with cost variance and schedule variance. You want to see how much have they deviated from what we expected that cost to be, from what we expected the schedule to be. Cost variance, the formula is given. Budgeted cost of work performed can be considered the earned value. So I'm reading in the middle of that paragraph. Understand that BCWP is the same thing as the term earned value, just in case either word is used. And so it is the earned value, BCWP, minus what I budgeted for, versus what the actual cost of work performed was. That is my cost variance. That is one formula. The other formula is for the schedule variance. Same thing. Schedule variance is the budgeted cost of work performed, what I budgeted for, and how long you told me it's going to take to get the job done versus the budgeted cost of work scheduled, what the schedule actually is, how long it actually takes you to do it. So you have to determine, is this a favorable action, unfavorable, or is it on target? This is exactly what we agreed upon. That's on target. Is it higher? Is it lower? Is it taking a shorter time to develop the item, or is it taking a longer time? Those are the kind of questions that you have to answer in this process. So the chart on page 39 is probably something you may see again, and let's look at it. So what you have for earned value management, you have various projects. You got project A, B, and C. You have the planned work, budgeted cost of work scheduled, BCWS. You have schedule variance is what you're going to have to calculate. So just imagine that's blank. Then you have budgeted cost of work performed. That's the value of the work done. Then you got to develop cost variance based on the actual cost of work performed, ACWP. So let's look at the example. So for this particular project, project A, the plan we planned based on the schedule, the plan was to pay $487 based on the schedule. So it's like two charts in one. And I got to compare it to the BCWP, which is the value of the work once it's completed. So if the planned amount is equal to the budgeted amount for the schedule, it's on target. That's an easy one. The issue comes in, let's say project B. I schedule excuse me, I schedule to pay $250, but the value of the work once you completed it on schedule was only $217. So that is an unfavorable schedule variance. I want it to be worth more after the schedule is up. Likewise, project C. The planned work or the budgeted work was $719. Once you finished by the schedule, the value of the work was $847. So based on the schedule and when you got the job done, that is considered a favorable variance. The other part of the chart is where you compare the BCWP and the ACWP to get the cost variance. So I'm just going to hide schedule variance. So if the value of the work done is $487 and I paid $487, that is cost variance is on target. Strictly cost, think cost. If the value of the work was $217 and I paid $122, hey, that's good, favorable. If the value of the work was $847, but I paid $875, that is an unfavorable transaction. And so that is kind of what you're going to have to do. You calculate schedule variance, cost variance. If not the dollar amount themselves, you're going to have to calculate, okay, what's the schedule variance? What's the difference? Whether it's positive or negative, you're going to have to say, is it on target, favorable, or unfavorable? Page 40 and 41 is just different ways in which to show the progress of a project, whether using the PERT chart, which is a method used to identify various tasks, or the Gantt chart, scheduling the project, planning the project, so you can just review that. So that is the cost part of it. Now, page 42 starts off with economic analysis, because we also understand if I'm coming up with a program baseline number, that the value of the work today or the dollar today will not equal the same in the future. It's actually going to be worth less. So we have to consider that when we're coming up with our cost estimates. So the economic analysis process starts on page 44 to 45. How to identify benefits, right? Are we saving money? What type of benefit? Is it a quantifiable benefit that I can put a dollar amount that we're saving? Or is it a non-quantifiable? Are we increasing the morale of our team because we change a particular process? So you have on page 46 is quantifiable. Cost savings, cost avoidance, something I no longer have to pay for, or productivity improvement. Those are your quantifiable. Then they give you some examples on page 47 of types of measure and sample measures of quantifiable type of benefits that I'm not going through each one. Non-quantifiable. Is the system adaptable? Is it available to everyone? Does it increase security, safety? So those are not things you can actually put a dollar on. And the examples on page 49, you got a long list there, but they are important enough in that development of that capability. So know that you have quantifiable and non-quantifiable. And since the list for quantifiable is only 3, definitely know those, so you know if they say, okay, what are the quantifiable benefits, or which one is not a quantifiable benefit, and you have a multiple choice test. If you know those 3, you'll be able to pick out the 4th one that's not correct. Statistical measures you may have to do if you're doing a cost analysis, an economic analysis. You're going to have to do a little bit of statistics. So you're going to look at measures of central tendency. What's the tendency of this data to act a certain way? So you may have to calculate on this exam the mean, the median, the mode. If you're given several lists of group data, item 1 through 5, let's say, and this number is 1, 2, 5, 5, 6, 4, and they say calculate the mean, you need to know you add up all the items, then you divide by how many items you have. That is your mean. The median, you put the numbers all in order. So let's say I have the number 1, 2, 3, 4, 5, 5. I put them all in order. Even if it's jumbled on the exam, I put them in order first. Then I go to the question. Median is which number is in the middle. If I have 1, 2, 3, 4, 5, and 5, then the median number is actually 3.5 because it's between the 3 and the 4. That's your middle value. The mode is the most repeated number. So in my example, the mode is 5 because which one is repeated the most? It's the number 5. So make sure you know how to calculate the mean, the median, and the mode. Page 52 talks about measures of dispersion. Indicates how the data is distributed. The most common measures of dispersion are the range and the standard deviation. I haven't had anybody who said they actually had to calculate the standard deviation, whether it's 1, 2, or 3 standard deviation, but you may have to calculate the range. So once you put the numbers in order, 1, 2, 3, 4, 5, 5, you take the highest number minus the lowest number, and that is your range of data. So I'm going to leave it kind of simple there. So you don't have to go any much more detail than that. Number 3 on page 53, frequency distribution. So once you have your data and your results, you're going to kind of look and see what type of graph are you going to build. Histograms, that's the bar graphs on the left diagram. Test scores. So if you have several test scores, Your bar graph is called a histogram. Or you can use the frequency polygon, which is the one on the line, like a line graph. So it's the same thing as line graph and frequency polygon. So this is line graph. Your data can be skewed. So depending on how the picture comes out, is it a normal bell curve? You got the middle number, you got some numbers on the left, some numbers on the right, or is all the numbers on the left and most of the numbers on the right? So based on the diagram on page 53, you have, it could be positively skewed or negatively skewed. And let me see something. So on the bottom of page 53 in that last paragraph, your skewed data. So the positively skewed data, because the tail falls off to the positive direction. Conversely, in the chart, time to failure, we see most of the data on the far right and the tail falls off in the negative direction. It is called negatively skewed. That means something else is going on. Why is the data not evenly distributed? So it makes you have to, so you're going to have to know whether this is a positively skewed data based on the diagram or negatively skewed. On page 54 at the bottom, inferential statistics. So I'm going to go over the examples because I've often see on various cost exams, they have this type of questions. Your supply department had 100 engines on January the 1st. By February the 1st, that 100 dropped to 75. It says, by what percentage did the inventory change? So what's the percentage change? It's not saying it's 100 minus 75. It's asking you for a percentage. So there's a way to calculate that. You take the 75 minus, so the new amount minus the old amount divided by 100 times 100, you have a negative 25%. That means it's a decrease in the inventory of 25%. That's your percent change. Same inventory on the next month, March the 1st, your inventory was back up to 100. Of course, you could tell, okay, if the inventory went up, it's got to be positive. So that should be one of, even if you don't calculate nothing, you know it at least got to be positive because you didn't lose anything, you gained. But is it an increase or decrease? So of course it's an increase. So even if you don't calculate or you forget how to calculate, is you know it's the increase change in inventory, therefore was a positive change. Because if I'm getting more in my inventory, it's probably positive. But let's say you want to calculate it because they ask you for the percentage, the number. It'll be 100, what it actually is now, minus what it was in February, which is 75, divided by 75 times 100, which will put you at 33% if you do the calculation. So the percent change from February to March is 33%. It's a positive change and an increase in inventory. So that is one area you need to also focus on because you may have to calculate the percent change. On page 56, we're going to look at, what is it, correlation, I think? Yeah, correlation of data. How does the data correlate with each other? If we're comparing, let's say, productivity to exam scores, is it the higher the people score on the exam, then their productivity increase? Or are we comparing in the middle, errors to examination scores? If the examination scores, the higher you score, you make the less errors or more errors. And the third one is you're comparing age to the examination score. So as you can see, positive correlation on the first one, right? So as examination scores go up, productivity also goes up. They have a positive relationship to each other. So I can compare productivity to scores. Negative relationship is in the middle when I'm comparing examination scores and errors. So between training scores and the number of errors. Therefore, it can be assumed the higher the training score, the fewer errors. So it's a negative relationship. So this indicates that the higher scoring individual will do work as of high quality. And examination scores, when they're all over the place, no correlation to each other. So I can't say, well, because if you're in a higher age group that you scored better because of your age, because the data is in kind of in the middle there. So there's no relationship. So you're going to need to know how to compare the data. Is it a positive relationship, negative, or no relationship? All right. Any question up to this point? Because the time value of money on 59, I'm going to have to slow down just a little bit more because there's a lot of moving pieces in this calculation. All right, I don't hear any questions. So time value of money. So going back to where I stated, we already understand that the value of the dollar today will not be the same in the future. But I got to come up with an estimate today to be able to get approval. So you have to look at the time value of money. So on page 60, for example, they have the present value formulas that's given. And oftentimes, if you see it on an exam, these will be given, the percentage. So depending, let's look at the bottom one. Year 1 through 5. Let's say you're developing an aircraft and the aircraft has a life cycle of 5 years. And I have to figure out how much it's going to cost to maintain that aircraft in those 5 years. Assume a 4% discount is what's given. They can tell me use the mid-year discount or the year-end discount. So we're going to focus on, let me see what they use on the example, the year-end. So on the example on page 2260, it has for year 1, the year-end factor 0.9615, year 2, 0.9246, and so forth. So keep that in mind. Moving on to page 61. On that chart. So I'm proposing cost and benefits. So if you look at the chart, you see item 1 through 6. Item 1 is the years since proposed investment, expected yearly cost, that's your sustainment cost, yearly benefit, end of the discount factors, enter the discount factors, and calculation, present value of the cost and present value of the benefits. So in year 1, in this example on page 2261, it says it expected yearly cost of $10 and the benefit is 0. That's the first year. So I'm going to discount that dollar in the first year. Year 0, which is not stated, is what the actual cost was. But now year 1 through 5, I have to discount. So the discount rate for year 1, based on the bottom of page 60, is 0.9615. And so I can calculate number 2 times number 4 is get my present value of cost is $9.62, and there's no benefit. Same thing for year 2, the yearly cost is $20 for that year. No benefit. But the discount rate for year 2, as stated on that chart, is 0.9246. Present value of the cost, once I multiply that $20 times 0.9246, is 18.49, no benefit. So you do all of that for each year, year 3, year 4, year 5, do your calculations, then you add up the present value of the cost. So we get what, 88.64 for cost and 135.50. So the present value of the cost will be $88.64. So me spending 100, it really only worth 88.64. On page 2262, we also look at break even. Once I make an investment, how long is it going to take me to get my money back, to earn my money back? So that's the break even point. So if you get a problem that lists the investment, what you initially invested, what your current savings are. So you take your investment divided by your savings, and it says, for this example, it's going to take you 4 years to earn all the money that you put in to this investment. 4 years. So you may have to do something like this in the future. All right, so the next few are practical exercises on the bottom of page 2263 and so forth. So I typically don't go over the exercises, but it's important for module 2. So I'm going to go over a few of these. And I got my development costs. All right. So life cycle costs. So as I mentioned, you're going to have to pull out, they give you total RDT&E, prime mission equipment, support items, initial spares, MILCON, O&M, and MILPER. And then at the bottom, they say, okay, what's the developmental cost? So you got to remember, developmental cost was all your RDT&E. So based on the data that's given on page 63, you can see that the total RDT&E is the development cost of 400 million. And then it says flyaway cost. Actually, while I'm doing that, let me exercise 221. I'll just do this. Flyaway cost is procurement of the prime equipment. Procurement of the prime equipment listed on the top is 600 million. Perfect. 600 million is your flyaway cost. Weapon systems cost is my flyaway, which is the prime equipment, and procurement of the support items. So let's see. Prime equipment is 600 million. Support items procurement is 50 million for a total of 650 million. Check. Procurement cost, everything that's labeled as procurement. So anything that has the word procurement on it, I need to add them all up. So I have 600 million for prime, 50 for support, 50 for initial spares, for a total of 700 million. Program acquisition cost, that's the PAC, because it didn't say unit cost, it said the program acquisition cost. So that's everything RDT&E, procurement, and MILCON for a total of 1,200 million. Operations and support is everything O&M and MILPER. So if you add that 740 and that 460 million, you get that 1,200 million, operations and support. And then the life cycle cost is the total of everything, 400 all the way down to 460, for a total of 2,400 million. So that's the answers for the exercises on page 2263. Page 2264, let's make sure you have the answers. This one is referring to the average unit cost of an acquisition program. So they have to calculate the PAUC and the APUC. So in the example, it says, after being used for developmental tests and evaluation, 3 units of the weapon system acquired with RDT&E funds have been successfully modified and are planned to be deployed. These 3 units or items are considered fully configured. So if they list in the practical exercise an item that is not fully configured, then you cannot include it in the total. So you can only total things that are fully configured. So I got 3 items, and then it says produced for acquisition. There are 297 fully configured items procured with procurement dollars. All right, so what's the formula for PAUC? Program acquisition cost is RDT&E, procurement, and Milcom. How many items do I have? I have 3 with RDT&E money and 297 for a total of 300 items from this example. So that's 300 items. That's fully configured. So the formula, let me make sure I do this, is the 400 million based on what's given, 700 plus 100 million. So you're taking from that example that we did on 63. That's where I'm getting those totals from. So the 400 plus 7 plus 1, or it's already been calculated for the program acquisition cost, is 1,200 million divided by 300 million will be 4.00 million. That is the PAUC. Then you also have to calculate the APUC, which is your procurement cost, so everything procurements. So let's see, everything procurement was procurement acquisition, 1,200 million. Let's see. Wait, choose different from there. So remember from the example at the top of 64, only the second bullet was using procurement dollars. The first bullet was using RDT&E. So do not use 300 items. You have to say 297 items. I was trying to see what the difference was because they're asking for procurement unit costs. And so it is 700 million divided by 297, which will give you 2.357 million. So that's how you do the PAUC and APUC. On page 65, unit cost in labor hours. You are given the units, unit 1, 2, 4, 8, and 16. You are given some of the labor hours, 190, 171, 153.9, and you are given the learning curve of 90%. So all you have to do is multiply 153.9 times 0.90, and unit 8 labor hours would be 138.5. Then you take that 138.5 and you multiply times 0.90 and you get 124.7. So in the, let's say on a test and they said, okay, what is the labor hours for unit 16? That is what you have to do, is you got to go through each one to get down to unit 16 hours. And then if they say unit 16, then the answer is 124.7 with a learning curve of 90%. Or the opposite on page 66, 2266, is you got to calculate the learning curve. So don't be confused when you see something like on page 66. If you're talking about the same item, the learning curve percentage is going to be the same. So you can either do it the way how I stated. If you're doing it on a test and you got 4 choices, is take that learning curve percentage multiplied by 700 and see if you get 595. Take the next learning curve percentage and see if you get 505, and so forth and so forth. So the learning curve rate is calculated by dividing the average cumulative time per unit into the previous average. For example, 595.0 divided by 700 will give you 0.85 or 85%. So if you're like me, I probably forget how to do long division. So I might not remember how to divide 595 by 700. So I do the easy way on a test again, and based on the answers they give me, I know that if I multiply the learning curve times the labor hours, it's going to give me the labor hours or the learning curve for the next one. So that's the best way how I can do it. Or if you remember how to do long division, then take the second hour or the 4th hour and divide it by the one before it, and you'll get the learning curve percentage. All right, so I think, let me see, that's it for today. Hold on. And yeah, we got time. All right, so I'm going to also go over the earned value management on page 67. Remember, you got two charts there. You're calculating the BCWS, the BCWP. You're coming up with the schedule variance. You're coming up with the cost variance. So you have to determine, is it on target? Is it favorable? Is it unfavorable? And so forth. And what is the value? So remember, the budgeted cost of work schedule, what I expect it to be worth based on the schedule. You tell me how long it's going to get you to do the job. If they're equal, they're on target. If the budgeted amount is $250, but once you finish it, it actually is only worth $216, then it's unfavorable, and so forth. Cost variance is taking the budgeted cost of work performed, that's the actual cost of the planned work, the value of the work versus what I actually paid. And so, for example, project B, if I budgeted to pay $216 and the value of the work once you were done is $216, but I actually only paid $122, that is a favorable cost variance. So just kind of go over these again to make sure you understand why on the schedule side is favorable versus the cost side, it might be unfavorable if that same thing happened. Okay, look like we are at the end. All right, so we have completed CDFM Module 2, Competency 2, Cost and Economic Analysis. I will pause for a few minutes to see if you have any questions. First of all, let me ask that. And then let's see, next week, while you're thinking of your question, next week we'll go over strategic planning and organizational performance management. I don't think there was any calculation in that section. That's more information purposes. All right, if there's no questions, I'm not going to linger any longer. This is Helen Thomas and the CDFM study group. If you have not already subscribed, please consider subscribing to our YouTube page. What it does, the more you click on a video or write a comment or subscribe, it then motivates the YouTube folks to promote the video. So anybody that types in Google and searches for CDFM study materials, CDFM, then those videos will come up because people are actually going to the YouTube page. So please consider subscribing. All right, this is Helen Thomas and the CDFM study group. I'll see you guys again next time.